So let's learn sets. Sets is just a well-defined collection of objects. So if you have a set like this and you are putting the numbers 1, 2, 3, 4, you can specify that as A is equal to set 1, 2, 3, 4, and you can define a universal set also, which means that the set is derived out of the universal set. If I say 8 and 9, this becomes the universal set. So if A is 1, 2, 3, 4, A complement, which is outside of A, will be set 8 and 9. Okay. Now element of a set can be expressed with this letter. So I can say that 3 is an element of A, or 5 is not an element of A. So these are some of the notation. Okay. Now if I have a set which is for example 1, 2, 3, 4, and I have another set which is 3, 4, 5, 6, there is union. So union of two sets can be denoted as A union B, which is like A union B is nothing but common elements. Common elements. So that is equal to, sorry, very sorry about that. Union of two sets means all elements. All elements. So that is like all the elements of set A and all the elements of set B. So what you need to write is, you need to write all the elements 1, 2, 3, 4, 5, 6, and no repeat. Okay. So remember, there is no repeat in the sets. And then the second one is intersection. So that is A intersection B, which is common elements. I'm very sorry about that. So this is common elements. So in that case, you find what are the common elements here. So it is like set 3 and 4. And this is the same case when you work with three sets as an example. And if you need to draw sets, you usually draw a universal set, and then you draw a circle and a circle, and this is set element A and B, and you can write it like 1, 2, 3, 4, 5, or something like that. You can put a dot and write it, and this is called Venn diagram. Okay, and for the Venn diagram, if you have something like, they might ask you to shade the Venn diagram. So if you have A and B, and this is a universal set, you can shade it A union B. How will you shade A union B? Which is like the whole of this portion, that is A union B. Okay, and if you need to shade A intersection B, it is this portion, it is A intersection B. Okay, and if you need to shade A complement means anything outside of A, so which will be all these portion. So remember that it will include B also. Okay, so A complement will include B also, part of B which is outside of A, and B complement will include parts of A also. Then there is set difference, which means that A difference B. So the format for A difference B is in A, not in B. So in A, not in B. So if you need to color it, it was like, or shade it, it is like this portion, in A, not in B. That is A difference B. And you have the cardinality of A, which is it's called the number of elements of A. So if you have A is equal to 1, 2, 3, 4, the cardinality will be 4. Okay, the same is with respect to the sets of sets which contain three sets. I mean the combination which contain three sets. So you have A, you have B, you have C. Okay, so A, B, and C. And if you need to find A union B union C, let me just write it here, A union B union C, it is this whole portion. Okay, A union B union C. Now if you need to write A intersection B intersection C, so that is the common of all the three sets, that is only this middle part. Okay, then you have then if you need to color A difference B union C, so they can ask any combination. Okay, so first what you do is first find B union C. What is B union C? B union C is the whole of this portion. Okay, so remember that whenever you work with sets, you have to think in circles. So this is B union C. Okay, and A difference B union C means what is in A, what is not in B union C. So which means that you have to color all the portion other than what I did here. So which is this portion. A difference B union C will be this portion. Okay, so you have to think and you have to plan it. I mean, you have to understand what they have given, and then you have to color it accordingly.